Okay, again, when we were figuring out our domain and our range, what we just did was, now don't let this one confuse you because we reflected it about the x-axis or over the x-axis, but if you think about that, that's a vertical change because it went from being on top to being on bottom, so that's a vertical issue. So we did not affect our domain at all. So the same domain you had at the very top of the page for the parent function is still the domain because you didn't do anything to change it. But we did change the range. So if you look at the graph on this one, I think it makes it a little easier to see. Always when you do range, you ask yourself how far down is this graph going to go? So I'm looking at the one that's in green. How far down is this graph going to go? Negative infinity. So that's how you start. That's always in parentheses with negative infinity. And then from there, I figure out how far up will this green graph grow. Well, it stops right there at 0, included or no?
Yes.
Yes, so it's a growth. Okay, so now we have to write the equation for the new graph. Anybody think they know how it goes? Where? In front of the x, in front of the square root, out in front of the whole thing. So it's going to be negative square root of x. You can check them both in your calculator, both of the family members, if you want to put them in. You already have the parent function in there. So if you want to check to see if you're right, you can just, I'm going to get rid of my table because I don't need it right now. Tab, let's see, the first one that we said, the control. On this calculator, if I need to be out of the square root sign, you arrow over. If you keep typing, it's going to keep extending the, so you have to arrow over to do the minus 30. Huh. And that is pretty much what our graphs look like. Yay us, we did good. Okay, delete, delete, delete. Yes, delete all that out of there. Now we have a new function. So a whole new family over here on the left. It says consider the parent function y equals 2 to the x power. This is an exponential. They give us the domain again. It says at the top of the page here that the domain is all real numbers. And then they gave us a table, so let's go ahead and put it in our calculator to get a table of data. So tab 2 to the x power. Control T, push your table up.
Yeah, mine doesn't. Yeah. Mine's like this. Yeah, mine goes like this. Oh, because yours is an 8 at the top, and I'm just doing.
Oh, my window?
Oh my god, her window is too even.
Yes.
A little over our shoulder.
Yes. Okay. Okay, I'll send her. Thanks. Is that why it's just, is it just,
Like, look at, mine's just a line.
Mine's just a straight line.
So if you
okay, if it's a straight line, you didn't put the x in correctly. It's an exponent. So, you use the exponent button. This is the exponent button.
Oh,
What I do is I just use the one over here.
Oh yeah, you can do that too.
okay, yeah, that makes sense.
Because our numbers are the same. So it's just.
Yeah, that's probably just because the scale is different. I set my scale yesterday for some reason. I just haven't changed it. So.
I like it.
Remember at the top they gave us the domain, but then the bullet asks me, what is the range? How far down is this graph going? It's going to 0. Now, we'll talk a whole lot more about exponentials later, but it is never going to touch 0. It gets as close to 0 as it can. Y'all understand the concept of you can half something forever, right? I can take the number 4 and half it, and that's 2, and half of 2 is 1, and half of 1 is a half, and half of a half is a fourth, and half of a fourth is an eighth, and half of an eighth is a 16th, and it never, ever goes away, right? So that's what this is. It's called an asymptote, and it's getting as close to 0 as it can get, but it's never going to touch 0. So our range is 0, not included. But then this arrowhead at the top indicates that it's going forever to infinity.
What did I need to fix?
I don't know. Is it a straight line?
Yes.
Okay, so you have to put the x's in exponent. So it should be 2 raised to the x power. This button over here on the left-hand side, right there, that little caret looking button, that's exponent. So you do 2.
What do you mean? Okay, hold on.
So putting a 2, like a square root of 2 is square root.
So it shouldn't be 2 times x?
It's 2 to the x power.
Okay, so x now. Oh, okay.
Okay, now we're going to use a different color, and we're going to sketch the graph of a family member that results when the y values are multiplied by 0.25. Just the y values. So you go to your table and you multiply each y value by 0.25. So I don't know if I showed you guys this yet, but because I didn't show the last class, now we're like, oh. Okay, so if you're in the graph and you want to just calculate, like I just want to multiply, this button right here that looks like a calculator, it'll switch these back and forth just real fast. So you just hit that little calculator button and it goes to the calculator page. So I need to do 0.5 times 0.25 because that's what they told me to do. And that gives me 0.125, which is the same thing as an eighth. So when I graph this point now on my new graph in my new color, I'm graphing the point -1 and 1/8. So it'll be a little hard to graph, but and then I multiply 1 times 0.25, so that's a 4. Then I multiply 2 times 0.25. When we did this, it says what happens when results when the y values of the parent function are multiplied by 0.25. The y values only. So we did nothing to affect our domain. So your domain is still the same as it was for the green function or the original. It says at the top of the page that the domain was all real numbers. Since I did nothing to change my x values, the domain is still all real numbers. In interval notation, that's negative infinity to positive. We did, however, affect our range. We multiplied by 0.25, but look at your range. It was 0 and infinity. What happens if I multiply 0 by 0.25? It's still 0. So your range is still 0 to infinity. what we just did was we multiplied every y value by 0.25. We did not touch the x value. Now I know that I've been telling you it's, in order to affect the x value, it has to be in the house. In this case, they don't have any parentheses or anything to indicate it, but that's because it's a tree house. So it's up here in the air. Anything that's happening with x would also be in the tree house. This 0.25 is not affecting x. It is only affecting the y values, which means it is not in the tree house. It's down on the line. So we're going to do 0.25 times 2 to the x power. Because this 0.25 is down on the line, not in the tree house. Okay? Third color. Sketch a graph of the family member that results when the parent function is translated 1 unit vertically. So do it, and I'll do it, and we'll see if I'm sure it's match. It was translated 1 unit vertically. Translation is addition. So I added 1. So I took all of my critical values and I just added 1. So to my y value only. So this one becomes 1.5. So that's this dot. This became 2. This became 3. That became 5. And that one would have been 9. So it was up there. So that's what it looks like. Determining the domain and range, well, again, I didn't do anything to my x's, so my domain should be the same as it has been. Negative infinity to positive infinity, which is the same thing as all real numbers. But my range did change. Right, we added 1. So if I go to my 0 and I add 1, this is now 1. And if you look at your graph, you can see that asymptote, it has changed. It's no longer at 0, it's at 1. It still isn't going to touch it, though. So your new equation would be y equals 2 to the x power. And then you have to come down on the line again. This cannot be in the treehouse because it was not a horizontal issue, it was all vertical, so I have to put a big plus front. Now we can plug it in our calculator, check and see if we're right. Plug them both in. So again, when I'm on the calculate page, I just hit the little calculator and go back to my graph tab and I can put my other 2 in.
I think you did it too.
Control T. Okay, so now that page is for you to use to help yourself. This one is for a friend. The very first one, let me help you with the calculator. There's a little calculator issue. first one says use the table to help sketch the graph of the parent function y equals log x. On your calculator, so I'm going to delete. They only gave you a couple of points here, so it might be helpful to just have a few more, or at least look at the graph on your calculator and see the basic shape of what it looks like. So on your calculator, if you'll look down here, kind of next to the 4, the 1, in blue, mine's in blue, yours is in yellow, hit control and that 10 to the x power, and it'll pull log up on your screen. So yeah, tap.
Oh, clean controller.
See how it's got 2 dotted boxes here, and the one on this page doesn't have one? That's because mathematically, if nothing is in that lower box on a page, they mean log base 10. And as a matter of fact, if I were to arrow to this box, and put an X in here, it will usually, yeah, it'll automatically, and just put the X or don't put anything, it automatically puts a 10 in the box. So, see, I didn't type that 10, it did that. So if you want to type the 10, you can, or if you just want to arrow over to the big box, that's where it's called the argument, but that's where the X goes. And so this is what the graph looks like. This is kind of important that you be able to see it. It kind of looks like it disappears down here, but it doesn't really. It's got another one of those asymptotes. So this is getting, on the X, it's getting as close as it can to 0, but never touching it. So that's how it's shaped. Just so you're aware. Okay, so they tell you to use a different color, sketch the graph. When the y values of the parent function are multiplied by 3, and then the resulting function is translated 5 units. So they told you the order to do it in, but even if they hadn't told you the order to do it in, if they had said vertically translate by 5 and multiply by 3, you always follow PEMDAS. So multiplication has to come before addition. So you're going to multiply all your y values by 3 and then add 5. Now what happens when I multiply undefined by 3?
So,
It is still undefined. What happens when I try to add 5 to undefined? It is still undefined. So that value is still going to be undefined, but your other values will change. Okay? So you can sketch in a different color what it's going to look like. So, multiplications first. Please excuse my dear Aunt Sally. We don't have too many X's in it. Oh, because right here, one of these will cancel with one of those, for sure. Right. Which would make, so that would make that. Did nothing cancel? No, you're not really, because you had it and you canceled it. Nothing canceled at all. Just the X.
the only thing that was closest was this, but I don't think.
Okay, wait. You still have too many X's. Because if these both still have X's in them, and those both still have X's in them, then you can factor out another X and still cancel an X. So it's like on top. Okay, except for no. Okay, you've got too many X's. Because if the bottom, okay. So at the very get-go, you can take 2 out of the top and 1 out of the bottom. If you take this one out of the bottom, then this becomes squared and there shouldn't be one to put back here. There shouldn't be 2 X's in this part.
So this is right, you did this right. You did that right. That's right. Okay, this is exactly right. So this is just x minus 5. There's not an x on this. It's just x minus 5. And then that's right. So take out x squared. So it'll be a minus, because this is a minus 7. It should be a minus 15. But then, so these will be, one of these will be 15.
I think that.
Okay.
30? 35. 10 times 3, 30 plus 5.
That's our problem. Okay, that's our problem. Can't be negative. Positive.
That's all I hear.
So that's right. This is negative, yeah. So then, what is it? What does it say? How do we put it? I think leave the x out of here.
That's the problem.
That one shouldn't have, it should be, it should be this. It should be, that's gone. There's only one in there, so it should be x and then we'll just do this too. Yeah.
Okay, now
That's why.
And then short plus 3, and then on bottom it should just be x minus 5. Yeah, take that x off.
Can you put a number in front of log?
Yes,
Okay. Is that kind of what our equation is?
yes.
Awesome.
So,
Okay, so
the
what?
equation, it would be, so it would be, 3,
You can.
X.
Yep, that's it.
Would you put plus 3 in this? No, plus 5?
If you put it in the house in
it's
parentheses,
with the x, so
then that's the x.
so you have to do x
You don't
plus
want it
5.
with the X.
So it has to be the x plus 5. There.
So this needs to put one? Okay, that's what you gotta use? Well, what is it? Yes. So I'm looking at that equation. Okay. Nothing is happening to X. Why they're not changing.
All, the every change that it should have is a y change.
Yeah, I have it outside.
You would.
Yep. I know, but it's plus 5.
Yes, yes.
It's plus 5.
Yes. But you also have to reflect it. And how do you reflect that? You're right, that's right. But mathematically, how do you reflect it? Which number-wise would you do the numbers? It was up here, yes. So you're gonna do that first and then add. So, And as far as whether you multiply or make negative or that doesn't matter. Those are the same level.
So, when my question was like this.
It's me? Nope, that's good.
Wait, you have your.
Yeah, so
Why did you do that? Yeah.
Wait, yeah.
Mine looks like that too.
Well, I did it wrong.
that's enough. He doesn't have it. It's good enough.
When it says green is vertically okay, well, I'm gonna go back. This is
Wait, what? Yeah, those look good.
Okay, so you're gonna finish this for homework. The stuff on the back is super easy. They have translated it already.
Like at the second part? Not that.
They have one of them's the original and one's the what's the original? The solid line is the original. The dotted line is the original, and you're just gonna explain the equation of what's happened. So this one's real easy to see, so let's do this one real quick. This is the original. What has happened?
translated.
It's been translated to the left, which is a horizontal change, which means when you write the equation, however many spaces it's been translated, which you can check it easily by checking this crossing point, it's in the treehouse, because that's a horizontal change, so it has to live with X.
Horizontal H is in the hole.
It's right, exactly. So if that's all you gotta do on these is just identify how it's been changed and write the equation. So the backside's easy.
How is it translated left part? Like,
Oh, I'm sorry, it's right.
okay, that's.
I keep looking at the dotted, thinking the dotted is the new one.
So the
It's not.
line is.
Dotted is original.
Are we going to y is equal to 2 right? What? Go behind it.
It's that weird thing.
The jars.
Garrett, remember if it's with X, it's backwards, what do you think?
Yeah.
Also, it'll be X plus 5.
It's probably 4.
It should be right.
Oh, sorry.